Okay, so in this topic we'll be looking at time and time zones and stuff, but in order to do that, we need to quickly recap how to talk about where we are on the Earth. Much like in flat space, we use two numbers. We measure position in two directions. So we can first measure up and down the Earth like that. We call that the latitude. So that's a measure of how far towards the north or south we are. And going along the other way, we can measure how far to spin across the Earth like this. So that's sort of spinning along horizontally to the east or to the west. And we call that the longitude. So again, that's how far east or west we are going. So to start with, it might be easiest to hollow out our Earth so we can see more clearly. The first thing to do is to establish something kind of like the origin in normal flat space, some sort of reference point to measure everything else from. In the north-south direction, it's really easy. We sort of just take this middle belt around the Earth, which you might know is called the equator. And it only makes sense to use this as our reference point in that direction. But in the east-west direction, we sort of just have to make a choice. And this kind of vertical line is the one we choose to measure everything from. We call this the Greenwich Meridian, Greenwich being somewhere in London, which is about here. So, look, that one was more a random choice, but that's where we will measure things from now on. Okay. Coordinates are then given with a pair of numbers. That should be familiar, but maybe confusingly, latitude comes first, so the measurement in the sort of vertical north-south direction is written first. So we start off at our kind of origin. That's where the Greenwich Meridian meets the equator. We'll think about longitude first, because we're on the Greenwich Meridian. That would be 0 degrees. We haven't moved anywhere yet. If we were to spin to our left, to the west, we could write a coordinate like 30 degrees west, like that. Okay, so we don't use negatives. Instead, we just write which direction we're traveling in, be it west or east or north or south or whatever. Okay. As far as the latitude goes, we're still on 0, and that's because we haven't yet spun off the equator. Okay, but if we say spin up like this, we could reach a latitude of, say, 20 degrees north. So the point 20 degrees north, 30 degrees west, would be the point right here. Okay, from the starting point, we've spun 30 degrees to the left, so west, and then 20 degrees up, so north. If we bring this guy back to the equator for a sec here, we can think about the range of longitudes, the sort of largest this yellow east-west number could get. Say we went all the way to something like, 200 degrees. We could spin that far, maybe. Okay, but we never actually write that. That wouldn't ever be written down like this. And that's because if we start from 0 all over again from the Greenwich Meridian, by convention, we choose to spin the shortest way there, which in this case would actually be towards the east. So rather than go a whole 200 degrees to the west, we'd just go 160 degrees to the east, and we would arrive at that same location, and by convention, we would use this smaller number instead. Note the relationship between the 200 and the 160 though. Since they make up the whole circle, as you can see, those two numbers will always add up to 360 degrees, and that's something worth keeping in mind once we start moving around and having to work out these numbers and so on. Okay, more on this soon. So what we see is that this longitude number maxes out at 180 degrees. Okay, 180 degrees is already all the way across to literally the other side of the world. Okay, any further, and you'd rather spin the opposite direction, as it would be a shorter rotation to arrive at that same spot. Okay, so coming back here to the middle. We can ask the same sort of question, only this time about the latitude, about the north-south direction. How high can that number get? In this case, spinning 90 degrees already takes us up to here. Okay, and this is the North Pole. You can't get any more north than the North Pole. So actually, the latitude reaches its limit at 90 degrees. And obviously the same restriction applies whether it's to the north or down the other way, so to the south. Once you reach the South Pole at 90 degrees south, you can't go any further south than that. Okay, so those are the limits to these latitude and longitude numbers. Let's take one more example, and hopefully this will serve as a screen you can pause and take notes on afterwards if need be. So once again, we start right in the middle. That's like our origin, our sort of 0, 0, but on around Earth. And that's where the Greenwich Meridian meets the equator. Let's spin, say, 90 degrees towards the east. That's what the longitude measures. Then from there, we can spin, say, 40 degrees to the north. Okay, and that would be the point 40 degrees north, 90 degrees east. Now, this might be a good place to pause and write if you want to note down these basic sort of definitions and ideas and the directions and stuff, okay? Typically, though, we might ask you to travel some angle in some direction and to write down the coordinates of where you finish. So say we travel from here 100 degrees to the east. Where would we end up? Well, only the longitude, the yellow east-west number, will be affected by that. So let's spin 100 degrees further toward the east. We find we're somewhere like this. But remember, the yellow longitude number only ranges from 0 to 180. Okay, but now we're at 190 degrees. That's past 180. So we know that we could reach that same spot by spinning a smaller angle to the west instead. So all the way along this way instead. And we know the number would be 170, because that's the whole 360 degrees of the circle minus the 190 we had before. So our new longitude would be 170 degrees west. Now let's travel 50 degrees south, say. Okay, first because we're at 40 degrees north, moving south only 40 degrees would take us right back to the equator. Then because we need to go 50 degrees south in total, we only need to go a further 10 degrees south. And that would be our new coordinates, so 10 degrees south, 170 degrees west. And so that's how we measure position on around Earth. We have latitude measuring from north to south, longitude measuring from east to west. Just be mindful of the ranges of these numbers and say when that longitude switches from east to west or vice versa when you travel too far in one direction. But that's all for now. Thanks for watching. See you around.